Hello, my name is Samuel Delgado, and in this project, I was a manager.
Hello, my name is Branson Stokes, and for this project, I was also a manager.
My name is Julian Flores, and I'm one of the spokesmen.
My name is David Flores, and I'm a reporter.
Hello, my name is ECE, and I'm the reporter for this project.
Hello, my name is Isaiah, and I'm also a reporter for this project.
Hello, my name is Alejandro, and I am a manager for the project.
Our problem statement in this project was to create a home alarm system to prevent break-ins. When brainstorming for this alarm system, we wanted to create an alarm system that protects a household when unattended and when uninvited visitors were trying to come in. So we thought of what basic needs an alarm system needed. While brainstorming and looking up research on Amazon and different alarm system websites that includes ADT, which is a high-rated alarm system site. A lot of these alarm systems have protected and notified homeowners of when open doors were open and when windows were also opened. We also did more research and saw that a lot of burglars have gotten away without face recording, and and a lot of homeowners weren't alerted when getting close to their household. So we also included a motion sensor to help alert homeowners, and we also included a camera to help prevent these break-ins.
Okay, so for the motivation for our project, in class, in the past, we've been learning a little bit about this topic. We touched this topic a little bit and how we could do it generally. And it just seemed a little bit more accessible for us and more interesting. A few of the specifics that we found interesting about this topic was the cameras and the motion sensors. The motivation for our part of our motivation is for the future and to design hardware and software for protection use. And overall, it just seemed a bit easier than the other topics. And it's a good starting point for us because we are all beginners.
So one way to sum up our project, at this moment, is that the description of it would be that we use Boolean logic as well as truth tables throughout our project to help with it. And our main source of code that we're using would be Python. The main project of our system is that it's an alarm system that's supposed to protect the homeowner's home while they aren't actually at their home. And to actually start the system, you would actually have to manually activate it to start up the system.
So the timeline of our project looks like the first meeting was during class, and we just basically talked about our roles and how we would get this project going. So our first real meeting was on October 27th. And in that meeting, we discussed the variables and we made a Google Doc and everyone was present on that day. Second meeting was on October 31st, and we just talked about more and define our project so we could basically answer it with our software and hardware. The third meeting was on November 8th, and we spent most of our time reworking the truth table and our variables, and we also sketched the circuit. So we made most of our project on that day, and we had a full attendance except one person. Our fourth meeting was on November 11th, and that meeting consisted of starting the software of the Python, and we chose Python as the software mainly because it was more easy and we had more experience in that. We also tried to find a way to connect the truth tables and to the coding of the software.
Okay, so in our project scope, the use of full participation helped us get through things done, as we came into this project, we knew that it would be groups like of 6 or 7. So it was helpful for us, since it wouldn't be like as a duo or as solo, since every group member will help each other out and it will get things done easier and quicker. We had an idea of what to work on, as in the hardware aspect. So as we came into this project, in one of our lectures that our professor was lecturing was the use of truth tables and the Boolean logic. And so he mentioned like an example on the home alarm system and how the truth table was worked and stuff. And so we like use that knowledge and implement that into our project, and like, figuring out what should we do for our home alarm system. And the different designs we use to develop this home alarm system. We use the basic ones as hardware, which is truth tables and the Boolean logic. And for the aspect of software, we use the Python, as previously members mentioned that it was more easier and we had more experience in using it as coding. And it would be challenging for us to work on it since it is through online, since we have everything online this school year. We've managed to figure out what our schedules are, and by organizing and like everyone saying their schedules, it was much more easier for us to go on about this project. We had different dates on when to meet up, and it was really useful and helpful in finishing our project. And the future of this project is to use it on Tinkercad and visualize the circuits and how it works. And by visualizing, we'll get to understand how we could implement the home alarm system in a real life world or situation that it will benefit us in the future as this major. And yeah, so ending on that note, that's our project scope.
Isaiah, if you could share your screen and show the software.
All right, 1 sec. And for our coding segment, David will start off by explaining the top half portion of the code, and I'll explain the rest afterwards.
Okay, so starting off with our software, we imported time into our software to make it seem more realistic. And we also imported sleep to delay the time it took for the variables to be ran into the software. Okay, and we also imported math because we were planning on using a random number generator to make it seem more realistic in terms of how the alarm would work. Also, we defined our inputs in binary because it made it more easier. The binary is also in true or false values, so 1 being true and 0 being false. And the first print of the function is to welcome the user to our system. And then we have a user input to activate or deactivate the system.
And for our first if and else statements, depending on what the user's input is, it will be stored as either active or deactive. And if it's deactivate, then the system will end up setting the print function of your alarm has been successfully deactivated, and that'll end up closing and ending the program right then and there. But if they end up activating the system and running the system as intended, then the first thing it does is that it will print that's checking the status of the doors, windows, and cameras, the variables inputs that we've set previously, and it'll end up printing either the door has been opened if the input's a 1, meaning that it was true, or if it's 0, then the door is secure. And basically this repeats for each and every one of the variables from door 1 to door 2, window 1 to window 2. And for cameras, if it's a 1, then that means that it would have captured an unidentified intruder. And if it's a 0, meaning false, the cameras wouldn't have captured any suspicious activity. And then we have a sleep function in order to give the system time, once again, to make it more realistic, which brings us to the final main if and else's, where we'll check if each and every variable, if there's a single one that's true, like in our truth table and our circuit gate that we made, it will print that the system sets off an alarm, and it will sound off or notify the authorities, as discussed as an output. But if none of them were activated and it equals 0 by adding all of them together, then no suspicious activity will be detected, meaning that there is no break-ins and the home is secure. And then as a final print, if the alarm alert is equal to 1, which it would be set to 1 if there is a single variable active, or 0 if there is none. If it equals 1, then it will print that the authorities have been called, the system has sent you a text alert, and the alarm siren has been sounded off, meaning that it successfully was able to detect the intruder and follow the protocols necessary. And if it's a 0, then that will indicate that there's been no break-ins, and it'll print out that there's been no authorities that's been notified, no SMS was sent out to the homeowners, and the siren didn't sound off. And the last else statement is if initially the input wasn't accepted properly, if it wasn't typed in as activate or deactivated, then this will allow it to notify the user that whatever they typed in as an input was not accepted, and they would have to rerun the program and either activate it or deactivate it once again.
Could you run the program real quick and show an example?
Sure. 1 second. So using this IDE, online IDE compiler, we could run the program, prints the first 2 print statements, and if we want to activate it, with our current variable set, it will read through and check all the variables. And it will say everything is secure and no suspicious activity because all of our current values are set to 0 or false, meaning no break-in. And this demonstrates how the code was effectively able to run properly with no bugs, no errors. Did we also want an example of either a variable being changed or?
Sure, why not?
All right. So if we were just to set randomly a couple of doors and windows were open, and we're to hit rerun, and if we were to reactivate it once again, as you can see, door 1 is secure because it's a 0, it's closed, but door 2 has a value of 1, meaning it's true, meaning it was opened, no printer prompt indicating that. The camera is also captured an unidentified intruder because it was also set to a value of 1. And after it checks all the variables, it'll also print the alarm system has detected an intruder, and it'll also let you know it's called the authorities, sent you an SMS alert, and an alarm has been sounded off. And that is it for the code section segment of our project currently.
Okay, and now on to our hardware section of the project. As you can see, this is the Google Doc we've been working on. We have defined a description. And as you can see, here are our variables, 1 being active and 0 being inactive. Here is the real world interpretation of that 1 and 0 as it would correspond to our variables, doors and windows being open and closed, and our camera and motion sensor having either 1 for motion or 0 for no motion. Our outputs, just like as Isaiah had shown on the software aspect, it had the notifying authorities and homeowner and the siren activating along with lights flashing. And here is our truth table. As you can see, we have our 5 variables here: door 1 and 2, window 1 and 2, and camera and motion. So we have all of the binary counting up from 0 to 31 in binary, along with another column right here where it adds door 1 and 2 and window 1 and 2, as if any of them are open, it would cause the alarm to trigger. Here's the column for that. As you can see, we added just those 2 variables. Say we added one from here and here, 0 and 1 plus 0 plus 1 is equal to 1, and 1 plus 0 is equal to 1. Therefore, in binary, 1 plus 1 is equal to 1, and that's how we got our answers for this column. And here is our last column where it adds everything together. It adds the variable, or it adds the value from this column to the camera in motion, and that would trigger our output here, LSN, for light, siren, and notification. As you can see, we added this column and this column together, and we got our answer. As shown, just like in the software, if any of these are open, then the alarm would sound off, resulting in a 1. If all of these are closed, then the alarm would not sound off. And here is the AND gate representation of our code. You can see here, as represented in the truth table, we have doors 1 and 2 and windows 1 and 2 being added together in an AND gate. And that value would be added with camera and motion. As you can see, they're added together by another AND gate. And whatever that value would be, it would result in our output. Okay. Thank you for watching our video, and goodbye.